Okay, today we are going to study the derivative of basic trigonometric functions. You should remember this from your previous course in trigonometry. You had 6 basic trigonometric functions. The other functions that we had were the inverse trigonometric functions. Remember, sine and cosine, inverse sine or arc sine and arc cosine. In this course we're just going to study the derivative of these basic trigonometric functions. We had 6 of them. Sine of u. U is a function of x. Okay, you should remember that u is some function of x. For example, I don't know, x squared, 1 over x, x to the third, etc. So you have sine of some function u, cosine of u, tangent of u, cotangent of u, secant of u, and cosecant of u. So the derivative of sine of u, the first one, this first rule, is going to be the derivative of your function that is inside the trigonometric function, u prime, and multiply by the cosine of u. Okay, you just copy cosine, and inside you are going to write u, your original function here. So it's pretty much the same with the rest of them. Cosine of u is going to be negative u prime, the derivative of u, multiplied by sine of u. We have a third rule. Tangent of u is going to be u prime times secant square of u. Okay. The number 4 is going to be, what's the derivative of cotangent of u? It's going to be negative u prime times cosecant squared of u. If you have secant of u, the derivative is going to be the derivative of u times secant of u multiplied by tangent of u. And the last one, number 6, is cosecant of u. Is going to be the derivative negative u prime times or multiplied by cosecant of u, and in time that is going to be multiplied by cotangent of u. So these are our basic rules for trigonometric functions, okay, for the derivatives of trigonometric functions that we are going to study. Okay, because most of you always ask for an example, so that's what I'm going to do. I'm going to work with some examples using these 6 rules in the next slide. So we have the next slide is going to be this one. We're going to write some examples. I can write function. Okay, we're going to start with the easier examples. And number 1 is going to be what if we have some function y that is going to be sine of x. Okay, pretty simple. Okay, what's the derivative going to be? Okay, according to our rule, I can start differentiating right now because I cannot rewrite this function. Okay, it's in its most basic form, sine of x. So the rule is telling me write u prime, the derivative of u. In this case, u is going to be x. So the derivative of u is going to be 1, right? The derivative of x is 1. Then my rule is telling me multiply that by the cosine of u. That means the cosine of x. So I'm done differentiating. This is my derivative. That's it. I'm just going to simplify. I'm just writing this function. Y prime, the derivative, my final answer is cosine of x. Okay, and that's it. That's the derivative of sine of x. The derivative of sine of x is cosine of x. I'm done with this example. Okay, so what are we going to do next? Okay, I'm going to work with another example. I want it to be, I think this is going to help you understand this subject. I want my function to be cosecant of x. Okay, I want it to be cosecant of x. So what's the rule telling me? Okay, it's in its basic form. I cannot rewrite this function. So it's going to be what's the derivative? It's telling me a negative. I have a negative sign here. U is of course x. Okay, whatever the function is that is inside cosecant of this expression here in this function. So my derivative of u is going to be again 1. Okay, that's my derivative, a negative 1, and it's going to be multiplied by what? Cosecant of u times cotangent of u. Okay, so that's it. This is my derivative. I'm just going to simplify. It's going to be y prime equals minus cosecant of x times cotangent of x, and that's the answer. Okay, so the derivative of cosecant of x is negative cosecant of x times cotangent of x. Okay, you can pause. That's a great thing about this. You can pause, you can rewind it if you didn't get anything. I think this is pretty easy. So let's work with another example. So you can understand this subject. What about if we have example number 3? I want it to be cosine of x squared. Okay, so as you can see, I don't have x as u. U in this case is x squared. So how am I going to work with this? Okay, so I'm going to start with my derivative right away. It says a negative, according to the rule that I presented on the first slide, it's going to be a negative u prime, the derivative in this case of x squared. What's the derivative of x squared? 2x. Okay, and this is going to be multiplied by the sine of u. So I just copy u x squared, and I finish with the derivative. Okay, I'm just going to simplify. I'm just going to get rid of the parentheses in this case. Okay, sine of x squared. Okay, and that's the answer. Please do not multiply this x with this x squared. Please don't do that. This x squared is inside the sine function. You cannot touch it. Okay, that's the answer. You can leave it like that. Okay. So I think they are pretty easy. Okay, we are not going to work with anything weird or anything. So let's work with another example. Okay, just 2 more examples. Okay, stay with me here. Number 4. This is example number 4, and I want it to be y equals tangent of x squared minus 1. Okay, I wanted to find the derivative of this function. So I'm going to start right away. Please, again, do not multiply x squared with tangent or minus 1 by tangent. Okay, and some of you may find it silly to do that kind of things, but some of you may, I don't know, try something like that. So my derivative y prime is going to be, according to my rule, it's going to be u prime. In this case, u is this binomial. Okay, this binomial is my u. Okay, I'm just going to work a little bit here, down here. So y prime, what is y prime going to be? Okay, so my rule says find u prime. Okay, what is u prime? The derivative of x squared minus 1. So what's the derivative? 2x minus 0 in this case. The derivative of 1 is 0. It's a constant. I multiply it by the secant square of u. So I just copy u, x squared minus 1. And this is the derivative. So I'm just going to simplify. It's going to be 2x times secant square of x squared minus 1. Okay, so I just write it. 2x times secant square of x squared minus 1. And that's my answer. Okay, so the derivative of tangent of x squared minus 1 is 2x times secant square of x squared minus 1. Okay, and the last example, number 5. Okay, this is the last example, I promise. Number 5 is going to be, I want it to be y equals secant of x squared minus 1. Okay, I want to find that derivative. So I'm going to use the rule that has a secant of u. So y prime, in this case, this is u. Okay, x squared minus 1. That is u. Okay, and so I start finding u prime. So u prime is going to be 2x minus 0, and then the rule is telling me secant of x squared minus 1 times tangent of x squared minus 1. Okay, it's a secant of u times tangent of u. Okay, and this is the derivative of that function, and I want it to be, I'm just going to simplify 2x times secant of x squared minus 1 times tangent of x squared minus 1. Okay, so that's the answer. Okay, so I hope this little video helps you understand this subject. I think it's pretty easy. You just need to learn the rules and how to use them. I think these examples will help you with that. And okay, I think that's it. Okay, we are just off to solve some exercises so you can master this subject. Thanks for watching.